I am going to draw a line. Doesn't matter what that line is. It's a distance, yes? I can't do any trig right now because I don't have what? A triangle. Everyone agree? Okay. What are the coordinates of that red point? Right, we've done a little bit of this already. X, Y, yeah? If I take that exact same line but I draw it in blue over here, what is this one? Negative X, Y. And then what happens when it's the green one? And what happens when it's the gray one? Right? Easy peasy lemon squeezy, yeah? We can't do any trig yet, though. Everybody cool? We do know some stuff about trig, though. We know that the sine of any theta in a right angle triangle is opposite over hypotenuse, yes? And the cos is? Adjacent over hypotenuse. And the tan is? So if I were to draw a right angle triangle right here, and I were to make that A, B, C, what would that make this little side? What would that make this side? Lil A. And this? Lil B, not a D, Lil B. And what does that make this? Lil C. And now we can do sine, cos, and tan of which two angles? A and B. And we would follow that pattern over H, A over H, and over A. Yes? Yeah. Right? Yeah. Okay. That is what you have to be 100% ready to move forward with. Are we? We all can do regular trig, right? And based on what we talked about the last time we talked about trig, you know that this thing, and now I've got a big version of it so we can actually do some work, you know that angles can go all around this thing now, yes? All right. So, I've called this section the unit circle, all right, because I want to explain something to you. If I draw, and don't draw this, if I draw a circle and pretend it's perfect, this is in the middle, yeah? So what is this? A radius. Everybody agree? No matter what the unit is, this and this are the same distance, yes? Everyone agrees? Okay. Now, if I make that triangle, oops, I should have used a different color. Is that blue line going to be longer or shorter than the red and the gray line? Longer, because it's hypotenuse, yes? Okay. Now, what if I told you, now, this distance you don't know, all right? What if I told you is that a radius? Yes. It is, right? Yes. Now, if I make a 90 degree with that, what do you know about blue and green? Shorter than red. And what else do you know about blue and green? They're the same size. They have to be the same size if this is 90 degrees. And this is a radius. Actually, that's not totally true because, of course, I could have gone up there, right? Okay, so let's dial back on that. That's coming in 2 lessons from now. I'm getting ahead of myself. You know what RJ said, that blue and green are both shorter than red, right? Okay, now we're going to do some drawing here. Okay, we are going to put a point out here. We know that point is XY. We've already talked about this, right? Now let's pretend that XY is on a circle, which means this distance is what? It's a radius. Everybody cool? All right. What is this distance, the blue line? How far is that? Can you tell me a number for it? So what do you have to tell me that is? Y. Because we went up to Y. Agreed? How long is the green line? X. Now, if I put theta right there, what is the sign of black theta? Right. But what else is sign? Isn't it O over H? So now we know that if we have coordinates, we can do some sign work. Right? We don't need O's and H's because opposite of this is the Y value. So sine is Y over, what's this? R. Everybody agree? What then is cosine of black theta? X over R. And what would tan of black theta be? Y over X. Everybody cool? Now there's a problem here, right? Because Y and X we get right from here, don't we? From the coordinates. If I told you that point was 4, 8, you would know what to do. What's R? You do know. What's R? R equals the square root of x squared plus y squared. Everybody cool? Yeah? All right. So now I'm going to put a different color over here, or a different triangle over here. I'm going to leave these the same. So what is this point now? Negative x, y, right? So how long is this side? How long is this side? Negative x. So what then is the sine of blue theta? Y over sine. Y over r. What is the cos of blue theta? Look again. Negative x over r. What is the tan of blue theta? Y over negative x. Interesting. Let us continue the pattern. Oops, sorry. Keeping the colors. I want to keep the colors. Light green theta. What's this? Negative y. What's this? Negative x. So what is the sine of green theta? Negative y over r. What is the cos? Negative x over r. And what is the tan? No. Y over x, because two negatives make a positive. Everybody with me still? And lastly, you already know what's going to happen here because you're very smart young people. Who just said they weren't? Don't be that way. Orange theta. What's this? What's this? What's this? What's sine of orange theta? Negative y over r. What's cos of orange theta? X over r. What's tan of orange theta? Negative y over x. Now please notice what happened to all three values here. They're all positive. All positive. Right? What's positive here? Cosine. C is positive. What's positive here? T is positive. And what's positive here? Sine. ACTS. CAST. I don't care. All of them are positive here, which means the sine, the cos, and the tan of every angle from 0 to 90 is what? Positive. The sine of every angle from 0 to 180 is what? Positive. What is the cosine of any angle between 90 and 180? Negative. What is the tan of any angle between 90 and 180? Negative. What is the tan of any angle between 180 and 270? Positive. Everybody picking up what I'm putting down? Why is R always positive? Because when you square a negative, you get a positive. Everybody cool? All right. Let's apply some of this knowledge. Yes. Number 1. 4,0 would be right there, yes? That's the terminal arm, right? Yeah. Well, the terminal arm is right on top of the initial arm, yes? So did it move at all? No. So that would be 0 degrees, yes? Now this is special because tan, on your calculator, whoever's got one going, what's tan 0? 0. What's cos 0? What's sine 0? I know. I'm waiting for people to push their buttons properly. Cos 0 is 1, and sine is 0. Okay. So, what over here? Oops. What's this one? Where's 0, 3? It's going to be up there, yeah? So that's a 90 degree. Now, we know that everything in here is a positive decimal, yes? Well, what's the sine of 90? 1. So automatically, what's the cos of 90? 0. 0. What's the tan of 90? 0. No. No. The tan of 90 does not exist. Because this is theta, isn't it? Well, there's no opposite and adjacents for tan, is there? Right? For sine, there's an opposite and adjacent, or an opposite and a hypotenuse. They're the same thing. So that's why hypotenuse divided by hypotenuse is 1, so the sine of 90 is 1. Everybody cool? Why is the cos of 90 0? Well, these are both adjacent to here, aren't they? So you can't pick one. Where's this guy going to be? It's going to be out here, right? So what's that? 180. Now let's be smart here for a second. You know that the sine of 0 was what? 0. And you knew the cos of 0 was 1, and the tan of 0 was 0, right? Yeah. What do you think 180 is going to be? What's the sine of 180? Guess before you punch it in.
1. 0.
Now punch it in.
I think it's 0 because it was 0 for 90.
So what is it when you punch it in? It is 0 because it's 0 for 90. Smart. Now, obviously, duh. What's this one going to be? What's that? 270. Now, if the sine of 90 was 1, what do you think the sine of 270 is? What's your guess?
3. 0. 1.
Try it. Sine 270. It's negative 1. Well, when it was up, the sine was positive 1. When it's down, it's negative 1. Cosine was 1 here. What was it here?
0.
Negative 1, because it's on the other side. Yes?
Isn't this what you told us on the last page? Because
Pretty much.
yeah, right. Because when we got to the 270 or the third quadrant, sine was negative, and after that quadrant, sine always is negative, right? Because before you said sine all the way from the 90 to the 180 angle, right?
From 0
From 0
to 180, sine is positive.
And
Yep.
after that, it's negative.
Yep. All right. Now, let's apply this to regular angles, right? Because, of course, those fancy angles, there's only the 4 of them in the whole 360, right? Which means there's 356 other angles, right? There's actually infinity other angles. So, let's apply this. First of all, we get our Cartesian plane, our coordinate grid, and we draw it. Where would negative 411 be? Left 4 and up 11.
Up 11.
Negative 4, 11. Agreed?
Yeah.
Okay. Let us do trig. That is the angle with which we are dealing. Yes, because we always start here. Agreed? Okay. What is the sine of red theta we know is y over r? Can I do that yet? Why not?
Because it's not a triangle.
Okay, I'll make it a triangle. But I don't need to, because we just proved that sine is y over r, didn't we?
Yeah.
So, do I have a y value?
Yeah.
What don't I have?
R.
How do we find r?
X squared plus y squared
Square root of x squared plus y squared. What is x squared?
X
negative 4 squared.
16. What is 11 squared? 121. So it's a square root of 137, yes? Now we're not going to do that. This is r. So what is the sine of theta? 11 over root 137. What is the cos of theta? We just talked about it. If sine is y over r, what's cos?
it'd be
A over R.
X over r, which would be?
negative 4 over root 137.
And what would tan of theta be?
Negative 4 over 11. Yeah.
No.
Oh, 11 over negative 4.
11 over negative 4. And if some of you are having trouble visualizing that, now I'll put the triangle on it for you. There's 11. There is negative 4. Is everybody good?
Yeah.
Okay. So now you guys try to do number 3 here. Sketch this. Just sketch it. Don't do any trig yet. Just sketch it. All right. Everyone should have it sketched by now. Where is it?
4 across, 3 down.
Right?
Yeah.
Everyone agrees? All right. So now, how far is this? And this? So how far is this?
Wouldn't it be -5?
How can it be negative? It's I square, right?
Oh, yeah.
3, 4, 5, right?
Yeah.
Everyone agrees? Okay. Now, I want the angle, right? So if I'm looking for an angle in trig, is this sine cos tan or shift sine cos tan? Shift. Now, when I have an x and a y, do I even need the r if I'm trying to find the angle? No, because we know that tan equals y over x, yes? And since I know I'm over here, tan theta equals -3/4, yes? So how do I punch that into my calculator? Shift, tan, I already get a bracket, -3 divided by 4. Now we know that's -0.75, but you know.
Oh, yeah, sure.
And what? Negative, you push the negative button.
It's literally the one right.
Okay. So, now this is weird, right? It's giving me a negative value. Right? Now, if I drew this triangle this way, 3, 4, that would be theta, yes? So isn't this triangle just exactly the same thing? So this would be 37 degrees if I use 3 and 4, right? This says -37. Why? Because I started from here, and remember, clockwise is negative, yeah? So this is 37 degrees. Is that the angle in standard position? No, of course not. Because standard position starts here and goes this way. Your calculator works with, what do we call that angle? Starts with an R, reference angle. Your calculator works with reference angles. So the reference angle was -37. What's theta?
360 minus 37?
So what is it?
323.
Everybody cool? All right. Turn the page over. Let's see if we can figure this one out. The terminal arm lies in quadrant 2. Where's quadrant 2? Up here. It's going to be somewhere up here, yes?
Yeah.
And tan is -9/5, yes?
Yeah.
And tan is y over x, correct? Okay. So if I've got to be out here, where's the negative going? X. -5, 9. And that is what it would look like. Agreed? Okay. Now, when I do that, that gives me this triangle, correct? I'm seeking an angle, aren't I? Shift or regular? Shift of what? Shift tan of -9/5. Now, will that give me purple theta or will it give me green theta? Try it. Punch it in and see what you get.
Where's that reference angle?
I just said that, I know. And yet nobody said it will give me green theta. Okay. Now, do what I asked you to do and actually punch it in. And what does it give you?
Negative 60.
Negative 61.
Oh, say I didn't round.
You got it.
Negative 61 degrees, yes? Which means I go to here, and negative is clockwise, yes?
Yes.
So this is 61. So what is purple theta? Because that's how we measure angles. No. 180 minus 61, which is 119. Is everybody cool? All right. Now, weird stuff's going to go down here. All right? This is only calculator work. It should literally take 10 seconds. Use your calculator to tell me all of these to 4 decimal places, which means I'm also testing you on your ability to round. Go. When you've got all those punched in, draw a Cartesian plane down here. What do you notice here? Harry, what are some things you notice? The tans are, well, 2 of the tans are the same, right? Because there's only 2 on there. Let's start with tan. Where is 10 degrees? Be right there, yeah? And where would the 10 be? Would it be pink or gray? Gray, absolutely correct. Now you will notice that when I come to 190, over here, what's this? 10. 10. And they both share the same tangent value. Because here, everything's positive, and here, tans are positive. Everybody cool? What else do you see that's the same? Just use letters. Just talk. A and E are they the same?
No, E and F.
E and F are the same, yes? Okay. So where would 223 be?
Third.
It'd be down here, yeah? And I'd go all the way around, and what would I find that was?
223 degrees.
But what would just this be? Well, what is it to here?
180. Oh, 223 minus 180.
Which is 43, right? And then the other one would be over here, yes? All the way around is 360, but I stopped there, right? At 317. So what's this in here? 43. They're the same reference angle, so they share the same sign. Why then is 43 which I'll change shades of red to do. I'll go to a pinky shade. Why is that one the same decimals but positive?
Because it's on the X and Y.
Because their X and Y are both positive. Everybody picking up what I'm putting down?
Yeah.
The value of your reference angle tells you where your terminal arm is going to be. Cool? All right. Let's try one last one together, and then you're going to be doing some work. Yo. Why would you do anything with 270? We only use reference angles. Reference angles are always between the x-axis. Right? 270 is not an x-axis. All right. Sine is negative. Could this line be there? No. Could this line be there? I was taught CAST. I go ACTS because I like to read clockwise. That's just me. Or you can just remember it. Like that's, you know. So I'll ask again. Could sine be there? No. Could sine be here? Says right there sine is negative. Can sine be negative there? No, because all my y values are positive. So sine has to be there or there, yes? Now, what do we know about these values? What's the 2?
Y.
It's a y value. So that is negative 2. What's that? What's this? No. 5. What's this? 5, because the hypotenuse is always positive. Why?
It's the square root of thing. Can it be square negative?
Okay. So now, what does this mean? This means there are 2 angles that share that sine value. How do we find the angle when we have the sine value? Shift or regular? So how am I going to punch that into my calculator? Shift sine of So where does the 24 go? Right there. Where? Tell you what, Jewel. Tell me when to stop the bouncing pink circle when I can write 24.
Ready, set, go. Stop.
Oh! All right. I don't have any more octaves, Jewel. I only got one.
Over time. Hold on, sorry.
24, and is either one of those the answer to the value of theta? No. Because those are reference angles. What is pink theta? 204. What is green theta?
360 minus 24, which is 336.
336.
Yay.
Everybody cool?
Yes.
All right. Now, I left you guys with quite a poop ton of work. Like all this SOHCAHTOA review stuff, yeah? Right? I know there's more above it. I left you with all these problems as well. So, here's what we're going to do. Obviously, SOHCAHTOA is quite a pattern, yes? You can do one or two of them, you can do all of them. All right? So, here, tonight, because we got lots of time left in class, tonight, what page are you on right now? 278. There is your work. 279. Don't start it yet. 279 to 280. That is what you're going to do tonight. Right now, we're going to take a few moments and we're going to go over a few of these questions. All right? Now, it shan't take long because I think I have these already done from last year. But don't quote me on that. Yo, yo. I can't remember what you guys decided because everybody's all over the map.
We had a decision.
You decided to have... Yeah. I think I said we were not going to do a test on trig, but there was trig on the final. All right. Here are the answers. Your page numbers will be different. The questions are the same. So go back until you find the page of Ike standing on the soccer field. 262. Here are the answers. Check them. Do not write them down. There isn't time. Just see if you did it right or wrong, and then ask. Okay. It is. You're right. It's down at 110. Usually I work at 150. 24.2. Ladies and gentlemen, please notice all the work is here. You can check it on the video. I have all the work. Theta, opposite, adjacent, and the work. Just look at yours. This one I'm going to take a second with because kids screw it up all the time. Angles of depression and inclination are always between the horizontal and where your eye looks. I bet if I walked around, I would find a whole bunch of you put the 15 in there. I would bet good money. This question always causes trouble. Okay. We'll come back to it in a second. Because that's one of the complicated ones we'll talk about in a sec. Nobody should have had trouble with 12. I found X and Z. I found the two numbers. I found them to be this. And then I go to my calculator at the last minute. I don't go to my calculator in the middle. 13. You had to use the pink triangle to get the hypotenuse of the green triangle so you could find this side of the green triangle. And there's the answer. The trees, I drew it for you. This question causes trouble amongst everyone. GHJ means I needed this whole angle at the top, from G to H to J. A great many of you don't read the questions well. If I told you I wanted the angle between Jordy, me, and Vicky, would you measure an angle between Jordy, me, and Luana? Of course not. You'd go Jordy, me, Vicky. JMV. GHJ. Okay? This one, I always draw it in two triangles, even though in reality, the wires were supposed to be at the same spot on the ground, yes? But that makes it confusing. Is this an art class? No, it's math class. So draw the triangles that will help you. Which is why I drew it over here and I just made them the same distance. Peeping Tom. I know it's a weird question. It was on a provincial exam without the names. It was just a person looks across at a building across the street. But the only reason you look across at the building across the street is to look at what's going on in there. You don't, if you live in an apartment building, a big tall one, and you look across at another apartment building, you don't look over there and say, damn, that's fine architecture. You look in the windows, just like you all do when you're walking down the street. If you see some person washing dishes at the window over their sink, you look at the person in the house. You all do. When you walk past an open door in your house, you walk past your brother's room, you look in. If the door is closed, you don't. Or if there's a tie on the door and you're, like, old. And then the last two are right there. Now, I know that Riley May wanted to see the road question. Did anybody want to see any of the rest of them? Yep. All right, we'll do the road question first. I don't know why the road question causes trouble every single year. All right. I'm going to draw a flat road. Everybody agree? Can everybody agree that that's a road? And it's flat. That's the road from Abbotsford to Chilliwack. Flat. Right? Yeah, it is. It's flat. Fine. It's the road from Calgary to Lethbridge. It's flat. Okay? Now, if you turn around your car and drive from Calgary towards Vancouver, you have to go over the mountains, yes? So that road will start doing what? Rising. The road rises 1 meter for every 19 meters along the road. The road has risen. Where does the car drive now? Does the car drive through the mountain and then take an elevator to the top? No, indeed, it does not. This is where the 19 is. So the hypotenuse is 19. Now, that's the way the road goes over a course of a rise of 1 meter and a hypotenuse of 19. Now, the question says the hypotenuse is how long now? 300. Right? So now I have two triangles, don't I? I have this black triangle that looks like this. 19 and 1. Agreed? But I also have this red triangle that looks like this. 300 and, I don't know, what is the same? That angle. Yes? So if I know that angle in the black triangle, do I know it in the red triangle?
Yes.
Yeah. So that angle is shift sine of 1 over 19. That will give me the black angle, yes? Everyone agree? Oh, it brought the red with it. Isn't that the same as that? So I know that this is this, yes? Well, in the red triangle, I want the horizontal distance, which is right here, yes? Well, if I know theta and adjacent and hypotenuse, can't I find it? Cosine. All right? And I believe the next question was Peeping Tom.
We don't have to do it.
All right. Harry. That doesn't help me. I told you I've got different page numbers. What question? Say a number of the question. What are you asking me? Just talk. I'll figure it out.
So it's like a window basically. With 8 triangles in it, and it tells you the wall.
Yes. Yes. I knew when he described it. Dude, if that's 30 and that's 40, how long is that? 50. All right. Are we good? Oh, the mountain question. I forgot the mountain question. And I also believe I assigned to you this review. Again, check your work. I warned you that number... Oh, you guys have different order, I think. Is your number 5... Your number 5 is the airplane one. Which I think I took out... Nope, there's the airplane one. Your number 5 is my number 9. The point is, it's a three-dimensional triangle, isn't it? Right? Because the plane is up in the air, but it also makes a triangle on the ground.
Do we have to write
Well, I did say I wanted it as a direction east of north. Remember we talked about north, east, 65. No. You're just seeing all the answers. So that was your 5 was the airplane one, right? What is your 6? The tree. That one? So there's that work. Which means your 7 should be the 2 trees, which is right there. And then this question is the direction question. I reminded you, this one is on the 0 to 360 scale. So straight north is 0, and we count that way. So the first triangle. Now, kids have a lot of trouble with this because it doesn't show up on your printing. there's a black line that I can quite plainly see from Curtis Point to here. But a lot of kids don't know that that's Curtis Point. So they do the question wrong. I've been meaning to fix it, but I always forget. And I forgot to remind you. So if you did it wrong, it's no big deal. You could have done the first one because it didn't matter where Curtis Point was. Armstrong Point, right here. I'll use a brighter color. Armstrong Point, right here. Fernie Island. Oh, so the boat leaves Roberts Point here, sails out to Coal Island, over to Fernie Island, and back home. That's this triangle right here. This in here has to be the 16 because north is 0. Now, I should warn you, ladies and gentlemen, listen please. The only stuff here that is crucially important that you're actually really good at is regular SOHCAHTOA. You're going to see, if you take Pre-Calc 11, you're going to see all that reference angle stuff again in more depth. If you take IB, you're going to see all that reference angle stuff in more depth. I talked to both IB teachers. They just wanted to make sure you had seen it. Okay? SOHCAHTOA is the most important stuff. Tomorrow we're going to do one more thing with trig that allows you to do trig when you don't have a 90-degree triangle. But it's just 2 formulas. Okay? Once you see how the formulas come about, then it's no problem. Then it's just fill in the numbers. Okay? Just like SOHCAHTOA, really. Once you learned what SOHCAHTOA was, it was no problem. And then you had the airplane question. There's the microwave tower. And there is the suspension bridge. All that has been recorded. Your job, as I said tonight, is to attempt page 279 and 280. Listen up for one more second. I'm going to shut up and you can have the last half hour to work on 279, 280. Listen, please. Tomorrow I'm going to teach a lesson. Like I say, you will get it literally like that. It's not a problem. Then I'll give you 1 page of work on it. Okay? And then I'll give you a trig review on this everything that's not SOHCAHTOA. All right? Now, you're obviously not going to have time to do that. You're not going to see it, me doing it, but I will record me doing it, the whole thing, step by step, all the way through. And you can watch that before your exam on, what day is your exam? Thursday. So you could watch it Thursday night. Okay? Wednesday night. Okay? Okay? Now, we are going to spend the first X amount of minutes on Thursday reviewing, yes? So listen to me. This is not a review. Okay, what do you guys want me to go over?
We're actually telling you?
No, this is what's going to happen Thursday morning. None of you say anything. Or you do what Mantosh just did and said radicals. That's an entire unit. There is no way you know nothing about radicals. Do you understand what I'm saying? Come here with useful, pointed questions. Not, can you show everything to do with factoring? Okay? Useful, pointed questions. Clear? Because if I decide that my time is being wasted, I'll just give you the test. All right? Everybody understand? I've shown you where to find pointed reviews. You have a book full of review. Everybody, unless you honestly get everything, everybody should be able to find something specific that they would like to discuss. Once that discussion peters out, we'll start our test. All right, go.